Hi, everybody. Thanks for coming. Thanks for taking some time and listening to me ramble. Talking about processing lots of things with very small things. So a little bit about me before we get going. I currently manage the Data Platform Foundations team at Okta, which is like event log, Okta system log streaming, underlying infrastructure, the system log API, stuff like that. Prior to stepping into my current role, I was a principal engineer on the defensive cyber operations team, which is in the security side of the world there. I like building stuff, invisible stuff, visible stuff, flying stuff, floating stuff, whatever. And my bird brain really likes shiny things, which sometimes it works out, sometimes it doesn't. This particular use case happened to work out, and I'm pretty excited about it. So, high-level overview of what we'll be discussing, the very high-level use case and some of our goals, why we chose to go the embedded OLAP route after seeing some of the problems with the particular use case of DCO and doing a lot of data processing there. I'll talk about the tools and the architecture that we kind of landed on as we're evolving and making things better. I'll discuss some learnings and observations from these systems, and I'll briefly talk about, from where we are right now, what we're excited about looking forward. So first and foremost, the DCO team at Okta, what we needed to do is pretty common. We needed to get data from a whole bunch of places. We needed to normalize it, enrich it with secondary data sources. We needed to model it for the end goal of ultimately like monitoring user behavior, doing like threat intelligence stuff, monitoring anomalies across a huge set of data systems, embedded canaries and tripwires in case, of the worst case really, which was then used to trigger downstream workflows. Basically, monitor a bunch of stuff and trigger these, sometimes pretty complex DAGs, other times not so complex. And philosophically, more so than anything, we wanted to provide the security team at Okta with like a single consistent place that they can go access the data that they need when they need it, which is usually they need it right now, and it's really important because they're running around taking care of important things. So kind of the initial version looks something like this, very, very consistent to the world of the modern data stack, pretty simplistic architecture. Obviously, I've simplified it here, but integrate a bunch of sources, throw it in S3, get it into Snowflake somehow. We chose the Lambda route. These particular data sources, if it's Workday, it's not very high volume. It's changing very infrequently. However, it's pretty important. If it's AWS CloudTrail across a very large number of AWS accounts or VPC flow logs or DNS query logs, obviously much, much higher volume there. So we had the once per day feeds, and then we had the continual pretty high volume feeds from other things. Obviously, Okta system log being one of those. Downstream of that, in the common ELT world, we landed everything in a raw database. Changes were being watched with effectively hundreds, if not like 1 to 2,000, like change streams on those tables. Signals were picked up, they were enriched, they were compiled and thrown down the line into these DAGs. And again, this is very similar to the world of MDS, and whether or not MDS is dead. The modern security data stack is looking like this, and it's just getting going. But what could possibly go wrong? Like, this is not the end state, it's just the initial wedge to provide a lot of value to the org. So first and foremost, the complexity in doing this is pretty high. Compliance dictates that we segregate AWS accounts. However, we want to get logs from all those AWS accounts. And the inherent complexity in those decisions means that CloudTrail logs are generated in one AWS account. They're sent to a second federated AWS account. Nobody has access. And sent specifically using a CloudTrail log destination. Pretty easy to do. However, you can't do that to the second hop of AWS accounts. So an S3 bucket replication policy has to be set up. So you're traversing AWS account 1, AWS account 2, AWS account 3, and then putting it in Snowflake, which is yet a fourth AWS account. In this case, again, using Event Bridge and Lambda. Not ideal, not really that pleasant, quite frankly. Talking to 3 different teams when anything goes wrong. The second being like spend and cost visibility from a very high level concept. So out of curiosity, how many people in here use Snowflake? If you do, raise your hand. So like quite a few people using Snowflake. How many of you who use Snowflake know exactly what a workload's going to cost before you ever run it? Sweet. I see 0 hands. Exactly. This is me. This is, I think this was a VPC flow logs from all of Okta's AWS accounts. This is like a $2,000 a day workload to just ingest into Snowflake, which is like 800 grand a year to provide no value other than data is sitting in the same place and can be accessed when it needs to be accessed. Very expensive, and I had no idea before I turned it on what it was going to cost. Clearly, we turned it off. The second big challenge here is within the world of Snowflake, and I've used Snowflake a lot. You have one of 2 decisions. Obviously, like there are edge cases now, or the newer stuff gets around this somewhat. However, for a very long time, you had to pick one of these 2 options in Snowflake. You either massively over-provision your virtual warehouses, and put it on a scaling policy, whichever you prefer. And you take no queuing in S3 or upstream of Snowflake. You're spending on that lack of queuing, but you're getting data fast. The other option is you incur a whole lot of queuing, and you fully saturate virtual warehouses, which obviously is, from a cost perspective, ideal. From an access, latency, et cetera, like time to initial use, it is very non-ideal. So pick one of your options. Neither are ideal, but depends on what you want to spend. And thirdly, like S3 upstream of Snowflake, and really, quite frankly, most data lakes that I've ever seen and or guilty have built, becomes a game of Tetris, where you have different data sources, and this is shaped like this, and this is shaped like this, and this source lands once per day, and it's the like really hard one to process, and this one's gzip JSON, this is not gzip JSON, this one's snappy compressed Parquet, this is TSV, the list goes on. And you just pile them all in S3, either one bucket or many buckets, and it becomes a total disaster. So how do you fix it? Like, where do you start with these 3 fairly large problems? So we basically took what we were doing, providing value, but obviously with the trade-off of being expensive or slow or whatever. And we looked at 2 of our primary workloads. The first workload is a small and continuous workflow. It's more like data streaming, whichever Kinesis, Kafka, doesn't really matter. And within this like small and continuous workflow, what did we need to do? Well, we needed to consolidate and normalize incoming data. We wanted a similar shape, at least all snappy compressed Parquet, please. We wanted to do our enrichments there because it happens fast. We wanted to generate a lot of metadata, like for this source, how often does it land? How big are the files? Like the very simple questions are very hard to answer. So metadata generation upstream of ever spending, at least in Snowflake. And the ideal kind of long-term goal was to actually move a lot of the signal harvesting to the small and continuous workload rather than doing it in Snowflake. And the secondary workload, which is requires probably more expense and it's more hypothetical than the first, was like threat intelligence stuff, ML training, data sharing to partners. Obviously, historical analytics is all done here periodically, and maybe never. Like some of these sources we may have never needed, but if we did have an incident and needed to use them, they were required to be there. So looking at these workloads, like what stands out very quickly is like, these really cool systems that I really want to play with and have not had the opportunity to do so are kind of perfect for this. Things like DuckDB, things like Data Fusion, obviously Velox, and more recently CHTB. So that's what we did. That's what I did. Chose to go the DuckDB route for this particular use case because it was very ergonomic, very easy to quickly get up and running, and very easy to get buy-in from people that would just run it locally, and then I could figure out a way to put it in production. So as sources land in S3, effectively what we needed to do is maintain a mapping of like source to an S3 namespace, whether that was a bucket, whether it was a path, whether it was a pattern of path, whether it was a file name explicitly, etc. So a source we mapped to an S3 namespace. We also mapped that source to the SQL that would basically model it upstream of Snowflake, as well as harvest signals from that particular source. So AWS.CloudTrail lands here in S3, and this SQL is used to break it out. CloudTrail is a really kind of interesting edge case, which required preprocessing upstream of Snowflake, period, because it's an array of one object, which has a single key records, which is an array of objects. You can't stuff it into a 16 meg variant column in Snowflake. You had to do all the processing upstream. So the SQL to take this mess and make it nice. And also that namespace or that source and that SQL file, or set of SQL statements rather, were then mapped to a Lambda function, pretty simple. And within that Lambda function, we basically packed DuckDB, we packed some other functionality of like, how big is this file when it comes in? How big is it when it leaves? When we started doing this, DuckDB's HTTPFS was like decent at multi-parting files from S3, but we found that Boto 3 was way faster. And you know, the more recent AWS stuff in Python is yet even faster. So you know, we chose to basically use DuckDB, but also wrap it with some other things. And each invocation effectively does this. So it does that normalization process. It schematizes stuff. It's all Parquet out the other side with like columns and metadata and headers and stuff. We ran SQL statements for harvesting signals. We unnested a mess. We appended metadata, like now. Very simple to do, but also very nice because you can measure latencies throughout the whole process. You can measure when it lands. You can measure when you processed it. You can measure how long did it take to process from a file-specific basis. You can left join to other sources, or you can go get your like enriching information and left join within a Lambda, which is pretty cool. You can do file-level deduping with Qualify. You can, well, file-level deduping with Qualify and like MD5ing things and fingerprinting and stuff. Really cool, like basically upstream of Snowflake, you can monitor incoming schemas, right? Take it to a table and do stuff with information schema and hash it, and now you know when schemas change. So all kinds of stuff we packed into this particular Lambda. And from that Lambda, we outputted it to a consistent, clean, normal place in an S3 lake, registered it in a catalog, and then background compacted it continuously for performance reasons. So it looks kind of something like this, right? Again, pretty simple, but you know, now we have a Wild West S3. We kind of have two-phase data processing architecture, if you want to get pedantic. You know, again, the pre-processing logic, SQL statements, signal harvesting logic, SQL statements, were registered by users. Lambdas are deployed, source-specific Lambdas specifically. Signals are generated, metadata is generated, and available to user long before it goes into Snowflake. So some of our heavier workloads actually never go to Snowflake unless we need to, and then we just flip that on because it saves a lot of costs. So, but yet it's still clean, it's still compacted in S3 upstream of Snowflake. And what we found is more of our security analytics people or the more sophisticated ones are going directly to this bucket. They actually don't need Snowflake because they like playing with DuckDB and querying these files directly. So fun benefits of this, by registering effectively source maps to a Lambda. Obviously, you have volume. Obviously, you have frequency. Obviously, you have a whole bunch of metadata there. Continuous, it's very cheap to get, quite frankly. You can monitor cost of, like, this source costs this much to preprocess, and it will cost this much if you want to put it into Snowflake. Obviously, we're still spending a little money to get that knowledge. However, it's like an order of magnitude off what it was previously, if not much higher. Some interesting things that I'm probably not going to talk about too much, but like when using Snowflake, Snowflake's on one budget. When distributing this out across a whole bunch of AWS accounts, cost remains proportional to other costs in that particular AWS account, which is very low on the stack of things that the CFO comes and yells at you about. And when it's consolidated into Snowflake, they just see this exponential spend, and nobody loves that. Pretty worrisome. So anyway, some stats and learnings. So in this case, top chart is basically the last 6 months of just invocations, about 1 million DuckDB invocations per day. We were at 2 million. We got better at basically batching and purging buffers upstream by sources, whatever, across a whole bunch of sources, which is kind of fun. Rows process. So one of the cool things, like after running Snowflake, after running Redshift, after running Hadoop and all these other systems historically, I've yet to see a system that, like, happy path can go, normal day processing 50 to 60 billion things. But like, hey, let's get a whole bunch of stuff in, or hey, let's add a new source or do a big backfill, spiking to 130 billion things per day. And like, I didn't have to touch any infrastructure, which is pretty cool. Digging into this a little bit, that day, normally, and keep in mind, these are not like primarily application logs. They're not metrics. They're not traces. They're not some of the super, super chatty like system level stuff. It's all like external data feeds. So like 1.5 terabytes per day. Typically, this particular day went to 50 terabytes. And again, we didn't have to change any infrastructure. Digging in even further to that day, like minute over minute spiking. So I worked at Shopify with some folks here historically, and we would see these massive spikes over like Black Friday, Cyber Monday through the January holiday season. And we had to do all this upsizing and get ready for these spikes, and it was fun and exciting. This is like, spiking 250x minute over minute. And I didn't have to touch anything, which is pretty cool. So this chart, 254 gigs per minute, and here I think it was running like 1 to 2 gigs per minute. So you go from 1.5 gigs per minute to 4.5 gigs per second, and nothing changes from an infrastructure perspective. It was kind of cool. We've done a whole bunch of, which I'm going to speak to a very high level here, just like by the nature of instrumenting stuff and by the nature of being able to experiment with AZs and lambdas over here and S3s over here, we have a pretty cool opportunity to kind of peek into S3 performance. What does Express One Zone look like? What does standard S3 look like? What does infrequent access tier look like, et cetera? This particular one, what is like a normal file size across the very diverse set of workloads or data sources? And on a P99, one particular source goes to like 3 gigs, but much more frequently here across our data source space, it's like a couple hundred megs when it lands. And diving into the under couple hundred megs subset, which is like 98% of these data sources, like most of those files on a P99 are like 28 megs. So like very realistic, lowish, medium latency like buffer purging across a huge array of systems. You still have a whole bunch of small files, which is kind of interesting. obviously for latency reasons or infrastructure reasons. So, another way of looking at it, like P95 is like 5 megs, P99 incoming, this is all data that's being dropped to us, is 17 megs. But something that's really cool that I was very happy about seeing this, like when P95 goes to 50 megs and P99 goes to 600 megs, again, we don't have to change any infrastructure, which is cool. This is S3 download performance. Basically, there's this information scattered about the internet sporadically. It's fairly consistent with what those people have seen. However, so P99 at 70 megs per second, P95 at 34, which is like not particularly great. However, when you're running this horizontally times 20, like that's pretty good throughput for a particular data source. The second chart is kind of interesting. So on this day that the files, or the size of the files skyrocketed, is that? Yeah. Download speed in AWS also, like I have no idea why, but it's kind of interesting to observe. We got like way better performance from a file level basis at, 1.5 gigs per second. And lastly, like watching the impact of something like this on Snowflake spend. Like I've seen very few Snowflake spend lines remain relatively constant and horizontal, and like ours has been, which is pretty cool. And lastly, very briefly, like taking what we have and looking to the future and like seeing, what are the current challenges, or like if we go to, more workloads where the large periodic workloads also have these systems primarily, what do we need to do that? What do we need to like plaster these systems through, production applications, which, obviously is the probably more common use case other than ingress. Like, what do we need? So first and foremost, like Lambda's cool. There's still a game to be played with resourcing of Lambdas. Obviously, it's not all set it and forget it. Like there is definitely some general, MO of sizing these things, and there's still waste. However, that waste has been taken from a even extra small Snowflake virtual warehouse to a whole bunch of little chunks of Lambda, but they still have to be over provisioned. It's just we're breaking them into more small chunks and following utilization curves better. Dynamically resourcing Lambdas would be so great. Right now, it's like it fails, it runs out of memory, it overruns the disk. We set it off to the side, reconfigure that, in automated fashion, try it again, and then scale back down for the rest of the workload. So dynamically resourcing Lambdas would be pretty cool. I know other people are more vocal than I about that. This one is like, I'm obsessed. And I'm looking at you, Andrew Lamb. Like, data fusion is amazing. Even more amazing within this is a table provider trait. And like, I think I saw the DLT people here. Okay, yeah, they're back there. You should do this. I like have nightmares of waking up and like, man, if I took data fusion and smashed it together with your stuff, it would be amazing. Because I just like want to run select star from slack.users or something like that, rather than doing all of these like data integration with Python and other systems. I'm just like obsessed with this idea, and it would help us out a lot. Because still, like upstream of S3 is not particularly, gorgeous, but working on it. So yeah, doing this would be really cool. Hybrid storage, obviously, like especially for read workloads, would be really amazing. We're looking at some really interesting use cases for basically like in-app analytics for the Auth0 side of the world. And we've done a lot of like back and forth there of like, what does it take? Is S3 good enough? Is the like highly variable latency reading from normal S3 like actually good enough for these workloads? Can we use express one zone? Like, do we have to cache it locally, like pull it through and, set it on a TTL, but then how do you keep it consistent? And like all these questions. This would be very cool. My second recurring nightmare. And then finally, well, not finally, there are certainly others, but this is another big one. Like echo management in data lake stuff is very difficult and certainly not solved. You can like shim IAM, you can bolt your own thing on top of it, but like even AWS IAM or GCP IAM stuff doesn't give you like column and row level granularity. So like, how do you do that? And there's just a lot of like unsolved questions here. OpenFGA is a pretty cool thing that the Auth0 folks are working on within Okta for the just FGA, which is fine-grained authorization, by the way. Basically like authorization graph and how do you do that in performant fashion. Obviously, Zanzibar at Google is highly inspirational. So yeah, just a TLDR, like this thing's not going away. It's only going to grow. Workloads only continue to expand, and it's pretty exciting. And in one particular case, this is data fusion actually being embedded into a whole bunch of other things. So like, not only is it being embedded OLAP being embedded into data pipelines and use cases within organizations, is being embedded into a whole bunch of products. And I see plenty of people here that are doing that. So cheers, it's exciting. That's all I got. So thanks for listening.